What if I told you humans might one day travel faster than light? Scientists just dropped a 2026 study that could bend space-time itself, unlocking secrets of the universe we've only dreamed of. Could warp drive technology finally be real? Watch closely because this could change everything we know about space. The 2026 warp drive study, published in a leading scientific journal, has captured global attention because it challenges long-standing assumptions about the laws of physics. For years, scientists have operated under the belief that faster-than-light travel was impossible, limited by Einstein's theory of relativity. According to these laws, nothing can exceed the speed of light in normal space. But what if, instead of moving faster through space, we could move space itself? That's the core idea behind the warp drive, and the new study suggests that it may not be as far-fetched as it sounds. The research team, consisting of physicists and engineers from several international institutions, conducted extensive simulations to explore how spacetime could be manipulated in controlled conditions. Their results show that under certain extreme conditions, spacetime can be bent, stretched, and compressed in ways previously considered purely theoretical. In essence, this means that a spacecraft could theoretically ride a wave of warped spacetime, effectively shortening the distance between 2 points without violating the universal speed limit. What makes this discovery truly shocking is not just the potential for interstellar travel, but the implications for our understanding of the universe. If spacetime is more malleable than we believed, it could have profound effects on cosmology, black hole physics, and even our understanding of time itself. The researchers emphasize that while practical warp drive technology is still far from being realized, the study provides the first experimental and computational framework for thinking about faster-than-light travel in a scientifically rigorous way. One of the lead scientists in the study stated that their work does not yet constitute a working warp drive, but it opens the door to possibilities that were once purely speculative. They liken it to the early days of aviation. Before the Wright brothers, humans had dreamed of flight for centuries, but it was only after rigorous experimentation that it became reality. Similarly, warp drive technology might remain theoretical for now, but this study brings it a critical step closer to plausibility. The concept of bending spacetime may seem abstract, but it can be understood through simple analogies. Imagine spacetime as a flexible fabric. Normally, a spaceship must travel along this fabric, limited by its stretch. But if you can compress the fabric in front of the ship and stretch it behind, the ship can effectively move faster than the speed of light relative to its starting point without breaking the physical laws that govern motion. This is the principle behind the theoretical Alcubierre drive, first proposed in the 1990s, which the 2026 study expands upon with new models and simulations. The simulations revealed several surprising findings. First, the energy requirements for creating a warp bubble, a region of compressed and expanded spacetime around a spacecraft, may be lower than previously estimated. Earlier studies suggested that it would require more energy than the mass of entire stars to achieve even modest warp effects. But the 2026 research indicates that under certain configurations, the energy needed could be within reach of advanced future technologies, possibly using exotic matter or quantum field manipulations. Another significant revelation concerns stability. One of the biggest theoretical hurdles in warp drive physics has been the potential instability of spacetime bubbles, which could collapse or create unpredictable gravitational effects. According to the study, certain configurations allow for surprisingly stable warp bubbles, potentially capable of maintaining their shape long enough to facilitate long-distance travel. While still theoretical, this addresses one of the major criticisms of previous warp drive concepts. The team also explored how warp fields could interact with gravity and other spacetime phenomena. Interestingly, the simulations suggest that warp bubbles could theoretically navigate around massive objects like stars or black holes without destructive interference. This finding is particularly exciting because it suggests that advanced warp drives could allow spacecraft to traverse regions of space that are currently considered too dangerous or inaccessible for conventional travel. The public reaction to this study has been electric. Scientists, futurists, and space enthusiasts worldwide are debating its implications. Could humanity one day colonize distant star systems? Could warp drive technology unlock secrets of the universe we've only dreamed of? While experts caution that practical application is still decades, if not centuries away, the excitement is palpable. The very notion that the fabric of reality itself could be bent to our will captures the imagination in a way few scientific discoveries ever do. Skeptics, however, urge caution. They point out that while the simulations are groundbreaking, moving from theoretical models to real-world experiments is a massive leap. The challenges of creating exotic matter, controlling energy precisely, and managing the effects on spacetime are enormous. Moreover, ethical and safety considerations cannot be ignored. Manipulating spacetime on even a small scale could have unforeseen consequences, potentially affecting gravity, time perception, or even the fundamental structure of local space. Yet, even with these challenges, the 2026 study represents a paradigm shift. For decades, the scientific community has approached faster-than-light travel as impossible. Now it is being considered a legitimate area of research, with concrete models and potential pathways for experimentation. This shift alone could inspire new generations of scientists and engineers to think beyond the limitations of classical physics, to dream bigger, and to innovate in ways previously thought unattainable. The study also raises fascinating questions about the nature of the universe itself. If spacetime can be bent, stretched, or manipulated, what does this mean for the concept of causality and time? Could warp drive technology allow not just faster travel, but insights into time dilation, temporal loops, or alternative methods of observing cosmic events? While these ideas remain speculative, they underscore the revolutionary potential of the research. Media coverage has been extensive, with headlines ranging from "Humanity One Step Closer to the Stars" to "Warp Drive Science, Fantasy, or Reality." The debate is no longer confined to academic journals. It has entered public consciousness, sparking discussions on social media, podcasts, and science forums. Educators are seizing the opportunity to engage students in physics, cosmology, and space engineering, using the warp drive study as a springboard for inspiring the next generation. Another intriguing aspect of the study is its interdisciplinary approach. Physicists, engineers, mathematicians, and computer scientists collaborated to model warp fields with unprecedented accuracy. Advanced computer simulations allowed them to explore scenarios that would be impossible to test experimentally at this stage. The integration of quantum physics, general relativity, and advanced computational methods demonstrates a new way of tackling problems once thought insurmountable. Looking ahead, the researchers outlined several next steps. First, refining the models to include more realistic energy sources and materials. Second, exploring small-scale laboratory experiments to test aspects of spacetime manipulation. While these won't produce a working warp drive immediately, they could validate the theoretical principles in controlled settings, providing critical data for future development. Finally, they hope to inspire collaboration across nations and institutions, recognizing that such ambitious technology would require global scientific cooperation. For space enthusiasts, the implications are breathtaking. Imagine reaching nearby star systems in years instead of millennia, exploring planets around other suns, or sending robotic explorers far beyond the solar system at unprecedented speeds. Beyond exploration, the ability to manipulate spacetime could revolutionize space logistics, interstellar communication, and even energy transfer. The possibilities stretch the imagination in ways that few scientific studies ever manage. At its core, the 2026 Warp Drive study is more than a technical achievement. It is a story about the human spirit and the drive to explore. It reminds us that limits exist primarily in our imagination, and that with creativity, rigorous science, and persistence, ideas once deemed impossible can move toward reality. It evokes the same sense of wonder that inspired humanity to cross oceans, climb mountains, and eventually step onto the moon. The study also serves as a reminder of how far science has come. From Einstein's theories of relativity to the development of quantum mechanics, humans have steadily expanded the boundaries of what is possible. Each generation builds upon the discoveries of the previous one, pushing the frontiers of knowledge. The 2026 Warp Drive study is a testament to this ongoing journey, a bold leap into questions that touch not only physics, but philosophy, curiosity, and our place in the cosmos. As the world digests this news, the conversation is likely to grow louder. Science communicators, educators, and media outlets are exploring ways to explain the complex ideas in ways the public can understand. Online communities are buzzing with theories, fan art, and speculative fiction inspired by the study. Even skeptics acknowledge that something revolutionary has occurred, a study that dares to ask, what if we could bend spacetime itself? In conclusion, while humanity may not be ready to board warp-drive starships just yet, the 2026 study signals a dramatic shift in how we think about space, time, and the laws that govern them. It challenges long-held assumptions, ignites the imagination, and opens the door to a future where faster-than-light travel may not be a dream, but a possibility. For those who have ever looked up at the night sky and wondered what lies beyond, this research provides a tangible connection to the cosmos and a glimpse of a future where the stars are within reach. The message is clear. Spacetime may be far more flexible than we ever imagined. The universe is not as fixed and rigid as once thought. With science leading the way, humanity stands on the brink of discoveries that could redefine travel, exploration, and even our understanding of reality itself. The stars are waiting, and the warp drive may one day be the vessel that carries us there.